All right, so for this session, we don't have a warm-up. I'm going to go straight into the study guide, so like that at least we get to at least half, and then tomorrow and Friday we'll finish the other half. Okay, here we go. Example 6Q on your blank sheet of paper, write this down. -2 times the absolute value of negative x minus, give me a number, 5, close the absolute value, plus 7 equals to 1. All right, so let's solve this. Now, as we covered this at the beginning of the school year, the second week, we said that we need to leave the absolute value by itself, which means what's outside of the absolute value on this side? We have a -2 multiplying and the plus 7. So let's get rid of the plus 7. So what do we do? -7 minus 7. That leaves us with -2 times the absolute value of negative x minus 5 equals to -6. How do we get rid of that -2? We divide by -2 both sides. Yes, because it's multiplying. Divide by -2. That leaves us with absolute value, negative x minus 5 equals to -6 divided by -2, that's positive 3. All right? So, do we have the absolute value by itself? Yes. We have a constant on the other side, so at this point we make 2 equations. One for negative and one for a positive. What do you mean, Mr. Q? Yeah. The 3 becomes -3. We write it equals to, and whatever is inside the absolute value, negative x minus 5. And on this one, on this side, it's a positive 3 equal to, again, whatever is inside the absolute value. All right, and let's solve. Start with this one. What do I do? Yeah, add 5. That leaves us with negative x equals 2. That negative is multiplying, so to cancel that negative, we divide by -1, divide by -1. And that leaves us with x equals -2. Solve the other one. Plus 5, negative x equals 8. Once again, how do we cancel that negative here? Well, we divide by -1 both sides, so that leaves us with x equals -8. All right, am I done? Pretty much, but let's write it in set notation. So solution set. What's the smallest of the two? Bless you. -8, comma, and then -2, and close your solution set. And then at the end, we just plot our solutions. Here we go. Graph a number line. -2 is right there. Plot your points. And -8 over here. Plot your points. And that's how you do example 6. From 1 to 5, how comfortable do you feel with these? Yeah? Okay, so I want you to go to the study guide. And I want you to do number 6 again. Bless you. Even if you already did it for home plate, do it again, please. Or copy that on your blank sheet of paper and do it again. Number 6, they give us -8, absolute value, negative x minus 6, close absolute value plus 10 equals 2. Do that by yourself. I'll give you some time. Copy. All right, here it goes again to make sure that we got the process. First things first, we needed to leave the absolute value by itself, so you subtract the 10 from each side. We end up with -8, absolute value, negative x minus 6 equals to -8. So far, so good. Then we divide by -8 both sides, divide by -8. That leaves us with the absolute value of negative x minus 6 equals to 1. So far so good, yes? From there, 1, we're going to write it twice, 1 as a negative and 1 as a positive. So this is negative 1 equals to whatever's inside, and positive 1 equal to whatever's inside. And then we solve. Plus 6 plus 6, negative x equals 5. Last but not least, divide by negative 1. X equals negative 5. This one, plus 6 plus 6, negative x equals 7. Divide by negative 1. X equals negative 7. Solution, negative 7, comma, negative 5. Hands if you got that. Okay, good. Our graph, negative 5, negative 7. From 1 to 5, how comfortable do you feel with these? Okay, good. All right, on your blank sheet of paper, write this down. Example 7Q, 7Q. For 7Q, before we go into the word problem, here's a setup for absolute value equations. Here it goes. You have absolute value x minus blank, close the absolute value, and we're going to make it an inequality, less than or equal to blank. Copy that, please. Or the other option is absolute value x minus blank, close the absolute value, greater than or equal to blank. You're like, I don't understand, Mr. Q. Well, for right now, just copy that. That's the setup when they're asking you to set up an inequality using absolute values. Now, once again, when we covered absolute values, we said that it's a distance from here to here. And when we started with absolute values, and I started with what number is 23 steps away from 0, we said it was what? Negative 23 and positive 23. So how many options? 2. Okay. However, this setup, every year I keep the question you guys ask, or some ask, Mr. Hugh, why is it always negative right there next to the x? Well, let me show you. That should be ringing a bell because we've been working with g of x equals a f of x minus h plus k. Does this look familiar to this? Yes. Because when we get to functions, guess what value is going to go in here? The h value. Does that make sense? Because we're getting closer to that function. Okay? But for right now, just to get us there, we're going to apply these two forms to the word problem. So let's go to our study guide to number 7. Number 7 on our study guide. And it reads, oh, look at the squirrel. All right, it reads, bless you. Solve each problem using an absolute value inequality. Okay, which means we're going to use x minus blank less than or equal to blank, or absolute value x minus blank greater than or equal to blank. Okay? So for right now, let's read the problem. On average, a squirrel lives 6.5 years old. Okay. A squirrel lives up to 6.5 years old. Okay. The lifespan of a squirrel may vary by as much as 1.5 years. Here the key word is what? Vary. Think about it. What does that mean, that it varies 1.5 years? Talk it over your ear. What does that mean, that it varies? All right, I think Miguel's got it, that it varies 1.5 years. What does that mean, Miguel? Very good, that it's either plus or minus 1.5 years. Is that correct? That's what it varies. It can be plus 1.5 years or minus 1.5 years. So what does that mean in algebra? Well, let me show you. Look up, please. Look at the previous absolute value problem that we did. Let me zoom in here. Look at this one. Here we have the absolute value, and here we have the number 1. Which of those numbers became plus and minus? The 1, yes. This became a negative and a positive. Okay? So with that said, if we go to our problem at hand, tell your neighbor which of these two numbers will go on the other side of the absolute value. Alright, so with that said, what goes there? Juliana? 1.5 is correct. 1.5. Copy that, please. Why? Because this one is what? Plus, minus. So if that's 1.5, what goes inside, Andy? 6.5, yes. And notice right now I wrote it as an equation so far because that's what we know what to do. But let's find out which direction we're going to do the inequality symbol. It says, on average, a squirrel lives to be 6.5 years old. That's the average. Could it be more than that? Yes, by 1.5. However, could it be more than that? No, that means it has to be less than. Less than. Alright, so with that said, let's solve this. Do we know how to solve this? Yes, Mr. Q, we have the absolute value by itself, so that means we're going to write this as a negative and as a positive. I'm going to bring down the 1.5, and I'm going to write it as a negative. Look up, please, before you miss this part. Think about it. I can't just write this as a negative. There should be a process that we can do in our brain to make this 1.5 into a negative. What would be that process? Audrina? Okay, she said the answer for the next step, but I'm saying, what do we do to 1.5 to make it negative 1.5? What do you guys think? Multiply times what? Negative 1. Is that correct? In our brain, can we multiply 1.5 times negative 1? Yeah, that gives us negative 1.5. So if we multiply times a negative, what happens to an inequality symbol when we multiply or divide by a negative? Switch. So that means we're going to write this inequality in that direction. Then write whatever's inside the absolute value. For the positive, it's just 1.5. The inequality symbol stays the same. And x minus 6.5. Alright? At this point, let's just solve each inequality. So here we go. What do we do here? Plus 6.5, plus 6.5. For those of you watching online, because they're working out. That's loud, my goodness. X is greater than or equal to 5. Yes. Okay, how about here? Plus 6.5 plus 6.5. X is less than or equal to 8. Yes. Okay. But this is a word problem. We can't just give these answers like that. We need to give a statement. Let me read the problem again. On average, a squirrel lives to be 6.5 years old. The lifespan of the squirrel may vary by as much as 1.5 years. What is the range of ages that a squirrel lives? Tell your neighbor a statement that you would write as your answer, please. All right? We good? So, statements. Newer. The squirrel, very good beginning, yes, squirrel. Squirrel, oh, I misspelled it, sorry. Squirrel, Good beginning, the squirrel will live, man, pretty good. The squirrel will live from or between, yes, 5 to 8 years, yes. Woo. 10Q. That's pretty good, huh? From 1 to 5, a comfortable are you with ease? Yeah. So what's I guess the most difficult thing is to set up your inequality. Okay? Let's move on. On your blank sheet of paper, example 8Q. 8Q. Well, it's number 8. I'm going to use the same one. Write down 3x squared minus 6 equal to 6. So for this one, they ask us to solve this quadratic equation 3 different ways. I'm going to start with the one that you guys love the most, which is using square roots. Square roots. To solve using square roots, we need to leave the x squared by itself. So if we need to leave this by itself, what do I do from here, Brooke, to start to leave x squared by itself? Close? Add 6, yes. Add 6 to each side. We're left with 3x squared equals to 12. Continue, Raymond. Divide by 3, divide by 3. We're left with x squared equals to 4. And last but not least, all square roots. That's why it's called square roots, yes? So then 4, we get x equals plus minus 2. So what are my solutions? Positive 2 and negative 2. Okay? Now that we are 100% sure as to what my solution is, now we can do the other methods. Let's go with factoring. Next method is factoring. For the factoring, I want you to write, next to the word factoring, I want you to write equal to 0. So like that, you remember that for this one, you need to set the equation equal to 0. So let's write the equation again. 3x squared minus 6 equal to 6. It's not equal to 0. It's equal to 6. So tell your neighbor what to do to make it equal to 0. Let's see. Philip, what do I do? Subtract 6 from both sides. Very good. So this now becomes 0. And we get 3x squared minus 12. Alright? So, they want us to factor. Well, it's not a trinomial. We can't use Power Rangers, right? It's not a difference of squares. We can't use square roots. So what do I do next? Check for what? GCF. Make a note for yourself. Check for GCF. What would be GCF for those two? 3. And we're left with x squared minus 4 in parentheses equal to 0. Now I can continue factoring. What does this look like? Tell your neighbor, what does that look like? If they forgot, tell them to write a note, difference of squares. So let's see, how do we know, Mr. Q? Well, it's a binomial, it's the difference, and let's see, can I take the square root of x squared? Yes. Can I take the square root of 4? Yes, if it's a difference, so this is x plus 2, x minus 2, then bring down the 3 equal to 0. Next, now that we have 3 different factors, we set them all equal to 0. 3 equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. Alright, is 3 equal to 0? No, that cancels, okay. And here we solve for this one, minus 2 minus 2, x equals negative 2, plus 2 plus 2, x equals 2. Did we get the same answer as over here? Yes. Different method. Alright. Last but not least, let's go to graphing. Yes? Your favorite? Yes, Mr. Q. Graphing. I'm going to write the same equation. 3x squared minus 6 equals to 6. And for this one, for graphing, whenever you see the word graphing, I want you to write equal to y. The equation needs to be equal to y. But right now it's equal to 6. So we first need to make it equal to 0. Is that correct? So what do? Minus 6 minus 6. 3x squared minus 12 equal to 0. And now I can change this to what? Y. Mr. Q, why do we need it equal to y? Because we need to make a table for x and y. The other way, you didn't have a y. So therefore, what values do I use for x, everyone? Everyone. Negative 2, negative 1, 0, 1, and 2. Okay. So, I'm going to rewrite this one without the x, just a parentheses, just to help me do my mental math and fill in my table. You guys can do the work on your own when you do the practice, but for right now, just for the sake of time, here we go. I'm going to start with the first value of x, which is what? Negative 2. So here we go. If I was to substitute negative 2 right here, what is negative 2 squared? 4 times 3. 12 minus 12, 0. There it is. Next value, negative 1. Negative 1 squared. 1 times 3 minus 12, negative 9. Am I going too fast or are we good? Yeah? Okay. Next, 0. What is 0 squared? Times 3. 0 minus 12, negative 12. Yes. Next, 1. 1 squared is 1 times 3 is 3 minus 12, that's negative 9. And the last one, 2 squared is 4 times 3 is 12 minus 12, that's 0. Alright, let's graph this. For x, we need from negative 2 to 2, and for y, we need all the way to negative 12. So I'm going to do this like so. So I got negative 2, negative 1, 0, 1, 2. And for y, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Negative 2, 0. Negative 1, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, negative 12. 1, negative 9, 2, 0. There it is. So we were like, okay, that's cool, Mr. Q. But what is the solution? Tell your neighbor what would be the solution according to that graph and why. Yeah, some of you are like, I don't know, Mr. Q. Well, for this one, that's why on the day of the final, you need to show me with arrows and write solutions. Why are those the solutions? These two, this one and this one, because that's where my graph crosses what? The x-axis. That is correct. The graph crosses the what? X-axis and negative 2 and positive 2. Did we get the same answers over here? Yes. That one was number 8. Yes? All right? Yeah. Let's go to number 9Q on your blank sheet of paper. 9Q. Copy this. Parentheses, 3 plus 5i minus, parentheses, 2 plus, give me a number, 9i. All right, so let's do this one together. What is this? A subtraction. So what is the first thing we do with subtraction, everyone? Distribute this into both terms, yes? So this becomes negative 2 and negative 9i. What do we do next? Combine like terms. So what is positive 3 minus 2? 1. Next, what is 5i minus 9i? Negative 4i, and this is our difference. From 1 to 5, I'll come to where with these. Yes, we did plenty of practice with these. So for the sake of practice, I want you to go to your study guide, and I want you to do number 9 by yourself again, even if you already did that. Just for the sake of practice. Give you some time for that. Copy and go. We got this, yes? All right, what you get for this one, Thomas? Go. 2 plus 4i for number 9. Hands if you got that. That is correct, okay? Let's go to our blank sheet of paper. Let's write example 10Q. Get it? 10Q? 10Q. Parentheses 3 plus 5i times 2 plus 9i. What are they implying here? Multiplication. Question, how many methods do we know how to multiply? 3. We know area model, distributive property, or vertically. Which method do you want to use? Distributive, okay, so let's start with 3 and distribute the 3 to the other terms. Times 2 and times 9i. So 3 times 2 is 6. 3 times 9i is positive 27i. Next, 5i times these two. So 5i times 2 is positive 10i. 5i times 9i is positive 45i squared. Can we combine like terms? Yes, right here, Mr. Q. So that gives us positive 37i. Bring down the 6 and bring down the 45i squared. Now, we're not done. Tell your neighbor not to forget the last thing at the end. What is it that we should not forget? Saul. The I squared is a negative 1. That is correct. So therefore, negative 1 times 45 is negative 45. Bring down the 6 and bring down the positive 37I. And now we just combine like terms. What is 6 minus 45? That's negative 36. Bring down the 37I. And this is our product. This is a complex number, so write a note for yourself. The imaginary is always at the end. The imaginary is always at the end. Yes? Oh yeah, I did that to see if you guys were paying attention. Negative 39. I love technology. Let's go. So, on your study guide, go to number 10. Do number 10 by yourself to get that practice in here. Number 10. Is on the screen, which is 7 plus 2I times 4 times plus 9I. Once again, you're doing this one again. Try to not look at your notes so you can get the extra practice. Copy and 10. We good? Yes? All right, what'd you get for number 10, Brianna? 10 plus 71I. Hands if you got that. That is correct. So double check your work. All right. Go to your blank sheet of paper. On your blank sheet of paper, I want you to write, let me see, example 11Q. Oh, hold on. 11Q. I want you to copy this circuit. This is example 11Q, and we're going to label this 5 ohm. This one, give me a number. 7 ohm. And one more. 20 ohm. There you go. And underneath that, just write current of 7.2 plus 9.6 I amps. All right? So, first things first, we need to label what we have in front of us, what each component is. So, tell your neighbor the name of this component. Very good. Resistor. Label it R. What is the name of this component? Very good. I for inductor. Inductor. And last but not least, this one is C for capacitor. Capacitor. Why do we need those labels? Because that's going to help us when we write our formula to find the voltage, to see what the impedance is. So first things first, we need to label our circuit. Second thing, you need to write your formula. V equals I times Z. V equals I times Z. Once you write your formula, if you're going to have your colored pens or highlighters, make sure you change the color of the I and underline that same color for the current. That's what you're going to use for that on the formula. Alright? So, with that said, let's find the voltage going through the resistor. So I'm going to write the letter R. And we're going to find the voltage. That means I'm going to use my formula. V equals I for current. What is the current? 7.2 plus 9.6 I. Then it says here multiply, so I'm going to put that in parentheses. And now the Z, let's see, I'm going to trigger your noodle. When we got to these, I changed this to green because that was the impedance. The impedance is the ohms, which is this. But do I write 5 ohm? No. For the resistor, we just write the real number 5. And then all we have to do is distribute and simplify to get our voltage. So what is 5 times 7.2? That is 36. What is 5 times 9.6I? That is positive 48I. And this is the voltage going through the resistor. Fairly simple, yes? All right, let's do it now for the inductor. Inductor. So I'm going to write voltage again, same current, 7.2 plus 9.6I. Next, times the impedance. What is the impedance of the inductor? 7 ohm. But do we write it as just a number? No. Now this is known as a what? Imaginary. As an imaginary. Alright? Let's find that. Let's see what we get. 7I times 7.2. 7I times 7.2, that's 14, that's 49, that's 50.4I. 7I times 9.6I. Positive 67.2I squared. And before we do the last step, tell your neighbor not to forget something on there. What aren't we supposed to forget? Everyone? Yeah, very good. The -1 for I squared. If you forgot, make a note for yourself. So, what is -1 times 67.2? That's -67.2. And what goes at the end? The I, positive 50.4I. This is the voltage going through the inductor. Next, we're going to the capacitor. Capacitor. Wow. All right. Once again, we write our formula. V equals multiply times the same current, 7.2 plus 9.6I. However, the impedance now is what? 20 ohm. And how do we write that? -20I. Negative imaginary. All right. So let's distribute that. Distribute. That gives us -144I. Is that correct? Yes? Okay, good. Distribute here. That gives us -192I squared. And tell your neighbor not to forget what? Man, good communication. Good. The -1. So negative 1 times negative 192 is positive 192. And then what goes at the end? The imaginary, minus 144i. Alright. So we're not going to do the other one here in class for the sake of time. You can do that tonight by yourself, but it's the same process. Let's move on. From 1 to 5. Are we do this? Yeah. Okay. Go to number 12. But on your blank sheet of paper, I want you to write example 12Q. Here we go. 5x squared minus 3x plus, give me a number, 6 equal to 0. So, for this one, they ask us how many real solutions or how many non-real solutions are there? Well, how do we know, Mr. Q? Do we need to solve it? No, for this one, we don't need to solve it. We need to start with b squared minus 4ac. You guys remember these? Yes? So in order for us to know the values, underneath here I'm going to write ax squared plus bx plus c. Does everybody see what we're doing? Yeah? So we need those values to substitute in here. So, what do I write for b, everyone? For b, everyone, negative 3. Yes, b is negative 3. How about a? 5 and c? 6. Okay, so let's simplify that. Negative 3 squared is 9. Negative 4 times 5 is 20 times 6. That's negative 120. Combine that, that gives us negative 111. Okay, what does that mean, Mr. Q? Well, let's find out what it means. Here's the table that I gave you some time back. If you have a number that's a positive, you get 2 real solutions. If you get a number that's a negative, you get none real solutions. And if you get the number 0, you only get 1 real solution. Now, for those of you that forgot, where did I get this b squared minus 4ac from, guys? Quadratic formula. And what is this is inside of a radical, is that correct? So think about it. If I have a square root and I have a positive number, don't we get a plus minus at the end? Yeah, that's where we get 2 solutions. However, if I have a negative inside of the radical, there's no such thing in real numbers. Therefore, they're what? Imaginary. And yeah, you get 2 imaginary numbers. And if you have square root of 0, what is square root of 0? 0. Only 1 solution. So I want you to go to the study guide really quick. I want you to do number 12 by yourself. For the rest of the time that we have 2 minutes. You should be able to do that in 2 minutes. Number 12. Copy that and... Alright, so in passing, this one you should have done b squared minus 4ac. Then you should have substituted negative 6 squared minus 4 times 9 times 9. That means this is 36 minus 300 and what? 24. Subtract that, that was negative 288. So therefore, if it's a negative, how many number solutions 2? Are they real or non-real? Non-real. There you go. So 2 non-real solutions. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.